All right, guys, this is note card number 5, which is on limits to infinity analytically. And so we're going to see lots of equations in this one, and we have to decide what the limit is as we approach infinity. For all rational functions, this is going to be fairly straightforward, and we're going to use Bo, Betsy, Boat-U to decide if it's going to 0, if it's going to a number, or if it's if the limit does not exist. And one thing to consider when we're doing that is that logarithmic functions are always going to be smaller than polynomial functions, which are always going to be smaller than exponential functions. So exponential functions are the biggest, and logarithmic functions are the smallest. And so we can basically start going down here and look at some of these. What you're going to notice about all of these limits is they're going to infinity. And once you see that it's a limit to infinity or to negative infinity, you can employ this Bo, Betsy, Boat-U rule. What we're going to notice about this first one is that the highest power on top is squared, and the highest power on bottom is squared. They're both polynomial. So they're even. The bottom power equals the top power. And so in that case, we're going to look at the coefficients. And the coefficient, we don't have to consider the 10,000 n because it's not squared. And as n gets really big, that term is not going to be significant. So we can really just focus on the 4n squared and the n squared. And if we look at the coefficients there, it's 4 over 1, so the answer is just 4. In number 2, we have a squared on the bottom, and we have a first power on the top. So it's bigger on bottom, and when we have bigger on bottom, the limit is going to be 0. So our limit here is 0. For number 3, as you can see, it's bigger on top. We have x to the 5th on top, only x squared on bottom. So if it's bigger on top, it's undefined, which means the limit does not exist. And that's right here. The limit does not exist. That's Boat-U. So it's bigger on top, it's undefined. The limit does not exist. So I'm going to write DNE for number 3. Number 4, this is a little trickier. They're not both polynomials. We have n to the 4th on the top, which is a polynomial, but we've got 3 to the power of n on the bottom, and that's exponential. And exponential is bigger than polynomial, so it's bigger on bottom, which means that this limit is 0. Number 5, here we've got a function to the power of a rational function. So the rational function is actually in the power. So if we just focus on 1 over x, then we've got a situation where it's bigger on bottom. X to the 1st is bigger than 1. And so as we go to negative infinity, or positive infinity, we're going to have a limit that's approaching this power, at least 1 over x is going to be approaching 0. But that is just the exponent. So essentially, we have 6 to the power of 0, because that rational function is approaching 0, and then 6 to the power of 0 is 1. So this is a little trickier. The limit here is 1. Moving on to number 6, if the graph of y equals ax plus b over x plus c has a horizontal asymptote at y equals 2, so what that must mean is that we've got a Betsy situation going on. The bottom is equal to the top in terms of the powers. So we're going to look at the coefficients, and that's going to give us our limit to infinity, or our horizontal asymptote. And so ax over x, the coefficients there have to be equal to 2, which means that a must be equal to 2. So a equals 2. And then we are also told that there's a vertical asymptote at negative 3. So what value of c is going to give us a vertical asymptote at negative 3? Well, that's going to be, if it was x plus 3 on the bottom, then a value of negative 3 would give us a divided by 0, which would give us a vertical asymptote. So c must be 3. c equals 3. And if that's true, then a plus c equals 5. And then last, moving on to number 7, for x is greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of the function f, which of the following statements must be true? So we've got a horizontal asymptote at y equals 2, and that we're looking for a statement that must be true. F of 0 equals 2, well, that doesn't necessarily have to be true. We could have a function where that is true, but we could also have a function where that's not true. F of x does not equal 2 for all of x is greater than or equal to 0. That is not necessarily true either. We could have y values at 2. So that's not necessarily true. It could be true, but it's not necessarily true. C, f of 2 is undefined. That doesn't have to be true either. The limit as x approaches 2 equals infinity. Now this would be a vertical asymptote situation because we're approaching a finite value for x, and we'd be looking at a situation something like that where we have a vertical line at x equals 2, but we're looking for a horizontal line. So D does not necessarily have to be true either. And so if we look at the last one, the limit as x approaches infinity is 2. That is what a horizontal asymptote would look like. So as we approach, maybe we have some situation that looks like this. And there's a horizontal asymptote at y equals 2. And so we see as we approach infinity, f of x is approaching 2, or y value is approaching 2. So we can cross D out, and E is the correct answer.